Hi, and welcome to another session of Dell Networking. My name is Humair Ahmed, and I'm a Senior Technical Marketing Engineer at Dell. Today we're going to discuss the Dell Networking S5000 Converged Switch. The Dell S5000 switch allows you to converge your LAN and SAN traffic, optimize and simplify your network for converged traffic with data center bridging, consolidate and minimize infrastructure hardware, and decrease IT management costs. Today we're going to view and understand the end-to-end solution, and then we're going to demo configuring a Dell S5000 switch for converged LAN and SAN traffic with FCoE. I just want to mention here, check out the Dell S5000 white papers on Dell.com at the link below. And with that, let's go ahead and get started. I've made the network diagram the background of my desktop. It consists of a server with a Broadcom 57810 CNA connected to a S5000 converged switch. This is all 10 gigabit Ethernet. The S5000 switch is connected to the Dell S4810 for LAN connectivity, and a Brocade 6505 fiber channel switch for SAN connectivity. The Brocade 6505 fiber channel switch is connected to a Dell compellent storage array consisting of one SC8000 controller and one SC220 storage enclosure. The yellow cables show the LAN side of the setup, where the S5000 sends all LAN traffic to the S4810 switch. The purple cables show the SAN connectivity from the S5000 to the compellent array via the Brocade fiber channel switch. The Dell S5000 acts as an NPIV proxy gateway. NPIV provides FCoE FC bridging capability on the S5000. The FC switch used, in this case the Brocade fiber channel switch, must also support NPIV. The Dell S5000 switch is connected to an FC switch and acts as an NPIV proxy gateway for respective end nodes. And with that, we'll first go ahead and jump on the server, which is a PowerEdge R720 server running Windows 2012, Windows Server 2012. So I already have a remote desktop connection. So we'll go on that and we'll double click this Broadcom Advanced Control Suite to take a look at our CNA. Oh, it looks like I may already have it open here. Okay, so we're using adapter 2, which is this adapter, and we're using port 0. You see 4 partitions here because we're using NIC partitioning is being employed. However, we're only using this first partition, and you can see it's enabled for both NIC and FCoE. If I click the virtual FCoE adapter here, we can see the worldwide port name. It's 20010008F7069251. Now let me double click the computer here, computer icon, and note there's only one disk. Once we configure the S5000 switch, we should see another disk here which will represent the volume on our compellent array. Right now we can't see that because the S5000 hasn't been configured. So this FCoE adapter here on our CNA port, the virtual FCoE adapter, hasn't logged into the fabric and can't see the disk. So let me minimize this and let's jump and take a look at our, actually let me close these windows first, minimize that, and let's take a look at our compellent array. I already have a window here to the storage manager. First thing, let's look at the controllers. So here we can see we have a fiber channel I/O card, and these 4 fiber channel ports are connected to the Brocade fiber channel switch. Let's take a look at the storage. You can see here I have 4 volumes. So I have 4 pods set up, and right now I'm actually on pod 2. So this is a volume that our server is going to be accessing once we configure the S5000 switch. And you can see all of these ports here are down right now because RS5000 hasn't been configured. So we have 4 connections here going to the compelling array from the fiber channel switch. Now, if I click this general button, I can see it's a 25 gigabyte volume. And if I click this mapping buttons, I see this object here called the PowerEdge Pod 2 server object. So if I come down here to servers and click PowerEdge Pod 2, you can see in there it shows disconnected again because the S5000 hasn't been configured. But if I click the server HBAs button, you can see that worldwide port name we saw on our server earlier. So what this is saying is this server object includes this worldwide port name of that FCoE adapter, virtual FCoE adapter. And this server object is linked to this volume, so that FCoE adapter can access this volume, and only that FCoE adapter can access this volume. I can come down here and add other adapters from that server, but right now I'm just using that one. So now that we understand that, let's go ahead and minimize that. And what we'll do next is we'll jump on the fiber channel switch. So I already have a console do that open here. And we'll enter the zone show command. And I see a number of zones in my effective zoning configuration. The zone I'm concerned with here is this one. So this zone, the first worldwide port name is the worldwide port name of that FCoE adapter on my server. And these other 4 worldwide port names belong to ports on the compelling array. So this zoning configuration is allowing these end nodes with these worldwide port names to talk to each other. Let's go ahead and minimize that. And before I jump on the S5000 switch and start configuring away, I want to mention something about this S4810 switch. I'm not going to go on this switch because there's really no configuration in here. I'm just using this switch to demonstrate LAN connectivity with SAN connectivity. Once everything is configured, I'm going to send LAN traffic to the switch and SAN traffic to the compelling storage array. So on this S4810 switch, the only configuration I have is this link is in VLAN 2, and I put an IP address on this link of 120.0.0.1. And then on my NIC partition down here on my server, I give it an IP address of 120.0.0.2 so I can ping that VLAN IP address. I'm going to do that while I'm sending SAN traffic once everything's configured to demonstrate that everything's working. And with that, let's go ahead and jump on the S5000 switch. So the first thing I'll do here is I'll configure the host name just so we don't get confused on what pod we're on. And then we'll configure the switch for LAN traffic. So let's go to the port connected to the S4810 on the LAN network. And we'll use the switch port command to put the port in layer 2 mode. We'll later put this we'll tag this port to the LAN VLAN. And let's go ahead and enable it. Now let's go to the port connected to the CNA on the server. And let's use the port mode hybrid command. This command allows the port to both carry tagged and untagged traffic. And again, let's go ahead and put this port as well in layer 2 mode, so we can put it in the respective VLAN next. And let's enable it. Now let's go ahead and create the LAN VLAN. We'll name it VLAN 2 since we're on pod 2, and we'll go ahead and tag the interfaces we just configured. And that's it for our LAN configuration. So now we'll go ahead and enable the fiber channel functionality with the feature FC command. And next we'll create a Dcp map and configure a priority-based flow control and enhanced transmission selection settings for LAN and SAN traffic. Now, priorities are mapped to priority groups using the priority-pgid command. In this example, priority 0, 1, 2, 4, 5, 6, and 7 are mapped to priority group 0, and priority 3 is mapped to priority group 1. So let's go ahead and configure that. And we'll call this SAN underscore DCB underscore map. So we'll give 60% bandwidth for LAN traffic and we'll turn off PFC. So 60% and PFC off. For SAN, we'll give it 40% bandwidth with priority flow control on. So priority group 1 and a bandwidth of 40% with PFC on. And we'll map FCoE priority 3 to priority group 1. So 0, 1, 2, 3, 4, 5, 6, 7. So you can see here we mapped priority 3 to priority group 1 for the SAN traffic or the FCoE traffic. Next, we'll create a FCoE VLAN and FCoE map and apply the DCP map to the respective interfaces. The FCoE map is used to map FCoE traffic to the respective VLAN and interfaces. The FCoE map is applied to both the 10 gig 040 interface going to the respective CNA port and to the FC interface connecting to the fiber channel switch. Note, on S5000, FCoE is always mapped to priority 3. So let's go ahead and create the FCoE VLAN. We'll give it a number of 1002. And next we'll create the FCoE map. And we'll name it SAN Fabric A. And now we'll link the FCoE map to the FCoE VLAN. and we'll designate the FC map used by the S5000 switch. For the FC map, you can choose any value within the given range, and you can see the range just by doing question mark. Okay, so now let's go ahead and go on the fiber channel interface. So we've configured the DCP map and we've configured the FCoE map, and we've already set up our configured everything for our LAN on the switch. But now we need to go under the fiber channel interface connected to the Brocade fiber channel switch. And that is, let's just make sure here, fiber channel, so that is port fiber channel 0/4. And let's go ahead and apply our FCoE map that we just created. And let's go ahead and enable this port. Now let's go to our port connected to our CNA so we can apply the DCP map and the FCoE map. Note the DCP map doesn't need to be applied because on the fiber channel port because it only applies to Ethernet. But the FCoE map has to be applied both to the fiber channel port and to the Ethernet port. So we'll first apply the DCP map. And you can see the PFC parameters match. So what's happening is the S5000 is actually pushing the configuration to the CNA port, the settings to the CNA port. And now we'll apply the FCoE map. And once we apply this, we should see the FIP snooping session come up right away. So we applied it, and there you go. The FIP snooping session is created, which means it logged into the fabric. The end node is logged into the fabric, and we can do some verification here. So to see the FIP snooping end node information, we can use the show FIP snooping enode command. And you can see here that the end node has logged into the fabric, and it's been given on FCoE VLAN 1002, and it's been assigned this FCID. So domain 0, port 1 on the Brocade fiber channel switch. Here you can see port 1, and then since we're using NPIV, session 0. So domain 1, port 1 on the Brocade fiber channel switch, and session 1 is the first end node to log in to the fabric over to NPIV. So some other commands we can use is show NPIV devices. This gives you a little bit more information here. We can also use show to see active FIP snooping sessions. We can also see the show FIP snooping sessions command. To To see FCoE map information, we can use the show FCoE map brief command. And for even more detailed information, we can use the show FCoE map and then give the FCoE map name. So in this case, SAN_fabric_A. So you can see here everything's seems like it's working on the S5000 side. The end node is logged into the fabric. The configuration looks like it's been successful. Now let's go ahead and test this out. Let's jump back on our server. So we're going to jump back on this PowerEdge server here. And I actually want to pass SAN and LAN traffic to make sure everything works. But before we do that, let's go ahead and take a look to see if our remote volume on our compelling array is not showing up. And there it is. You can see this wasn't here before, and now it is. So to test connectivity to both LAN and SAN, what we'll do is we'll send a continuous ping from this server here to this IP address on the S4810 120.0.0.1, and we'll copy over a couple files to the compelling array at the same time. So let me first initiate that continuous ping. So LAN connectivity looks good. Now I have a couple test files here I created. So let me move this up to the corner here. So I'm going to just copy these over while I'm pinging the S4810. Let's copy these over to the storage array. Looks like they copied. I had some other files already in there. And I'll copy them again. It'll ask me to overwrite it this time. Replace the files. So it looks like everything's working, and you saw here there was no disruption during the pinging. So that's it for this session. Thanks for watching, and don't forget to check out the Dell Networking S5000 white papers.